Hi, and welcome to my next video. This is a video on linear sequences. How do we find the general term of a linear sequence? I have another video which deals with the general term for a quadratic sequence, which is slightly more complicated than this, but the basic approach on both is the same, which uses simultaneous equations. If you need to update your knowledge of simultaneous equations, I have a video on those too, which you can search on the website. Okay, now here's our sequence. The first thing we do, we'll find the differences between the consecutive terms. So 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4, and 19 minus 15 is 4. So when the first differences are all the same in a sequence, means our sequence is a linear sequence. Now the general expression for a linear sequence I'm showing here in red, which is an plus 1. A linear sequence has n to the power 1, n being the position of the term in the sequence, like the first term, second term, third term, etc. And a and b are coefficients which we need to compute. Okay, the way we will approach this is that we insert n equals to 1. For n equals to 1, my sequence is a plus b. Now n equals to 1 gives me what my first term means. My first term is 3. So we equate that to our first term in the sequence, which is 3. Our second term, which is for n equals 2, will give us 2a plus b, and that is equal to 7. Now, for those of you familiar with the concept of simultaneous equations, here we have two equations. A plus b is equal to 3, 2a plus b is equal to 7. And we need to solve this for a and b. If I subtract the first equation from the second one, I'll get 2a plus b minus a minus b, and this will be equal to 4. So here I'll have 2a minus a, which is a, equals to 4. So that's my value of a. If I substitute it in any of these two equations, I'll put it in the first one. So I have a plus b is equal to 3. So I substitute 4 for a, I get 4 plus b is equal to 3, which gives me b is equal to minus 1. So my sequence, an plus b, is 4a, it's 4n minus 1. Now, it's good to check to see that we can generate this sequence from our formula. If I put n equals 1, for n equals 1, this will give me 3. For n equals 2, I get 2 times 4 is 8 minus 1, which will give me 7, and so on. And we can continue to check that this expression gives us every term in our sequence. So if I wanted to know what is term number 20, I would put n equals 20, and the 20th term would be 4 times 20 minus 1, which would be 79. Okay, we're going to have a look at another quick example. Here I have minus 1.5, minus 1, etc. This is the sequence we have. Okay, the first differences will be minus 1 minus 1.5. note here. I will write this longhand a bit so that we don't make mistake. That's minus 1 minus 1.5, which gives me minus 1 plus 1.5, which will give me a half. I wrote this longhand so that we are always aware of signs. So the first difference here is minus 1 minus 1.5, which will be 0.5. The next one would be minus 0.5 minus 1 makes that plus 1. So that will be again 0.5. So all of the first differences would be 0.5. Now, if the first differences are all the same, our sequence is linear, and the linear sequence can be written in the form of an plus b. So this is the general expression for our sequence. And we have to work out what a and b are. For n equals 1, I'll get a plus b, and that is equal to my first term, which is minus 0.5, minus 1.5. For n equals 2, I get 2a plus b, and that is equal to minus 1, which is my second term. Now I have again two simultaneous equations. It says subtract the top one from the bottom one. 2a minus a gives me a, and this one minus a minus 1.5. Let's write this in longhand. Minus a minus 1.5, which becomes minus a plus 1.5. So this gives me at a it equals to 0.5. As a general rule, the coefficient a is always equal to the first difference, if they're constant, that is, in this situation. So I have a is equal to 0.5, so I'll write 0.5 plus b is equal to minus 1.5. So b will be equal to minus 1.5 minus, so b will be equal to minus 2. So my sequence, let's write this in a different color. My sequence will be a is 0.5, will be 0.5a minus 2. Sorry, not a. Let's write it as n is 0.5 n minus 2. Let's do this right. There we are. 0.5 minus 2. So if I put n equals 1, I'll get minus 1.5. If I put n equals 2, I'll get minus 1, and so on. I hope you enjoyed the video. Give it a like and click on the subscribe button, and I'll see you in the next video.